Today we're gonna do happy number. Um, at first, it was pretty daunting to me because it was like a scary algorithm because I didn't really understand the math behind it. But then I brute forced it and then I understood how to solve it. So we're just gonna solve it today. Um, so we have this example. So what they did at first, they have n, which is an integer, any positive integer, and then they got the individual digits for each value. So if it was 101, it would be 101. So for 19, it's 1 and 9. So 1 and 9. And then they kept track of a sum variable to add them between them together while squaring them. So you actually had to um, get the 1, which is 1 squared is 1, and then 81, and then would equal 82. Oh, sorry, 82. And then they got that's the sum, and they kept on doing that until it equaled 1. So they would also do the same thing for 8 and 2. Um, and then they do that all the way until it's 1. So yeah, it's not a hard algorithm once you brute force it and understand what's not a happy number and what is a happy number. So yeah, let's just code it out. And we want to create a hash set to keep track of what has been seen, because we need something to tell us like, okay, this sum has already been seen. So yeah, we'll just create a hash set, integer, and we want to just say has equals new hash set. Yeah, we don't want to use a hash table or anything because it doesn't have a key. It's just like what has been seen. So for the first condition that we want to solve for, if it's not equal to 1, so while n is not a happy number, or the actual condition that we have to solve for is we want to keep track of the n equals no, sorry, in current, which would be the current number we're at, is actually equal to n, and then the sum that I was talking about before would be 0 at first. Cool. So then we want to say while it's actually valid, so while current does not equal 1, I mean 0, sorry, we want to take the sum plus equals the current modulus 10 because we're actually taking the individual digits between them, and then when you're squaring them you can just do this, but if you are doing like cubed or like not been like more than just squaring them, you would just do it 3 times 2, like, but this you only do twice. So mod 10. Cool. And then we divide by 10 to actually get the individual numbers between them. So what's it called? Yeah, so current divide by equals 10. Cool, that works. And now we want to say if has dot contains the sum. We just want to return false because it already contained the value that we actually had, which was the sum. That we don't have less code for, and we should just return false. But if it doesn't contain it already, we want to has that added to the hash set sum hash set sum, and then we want to say what do we want to say? We will be the n that we're at would equal the sum that, so then it would keep on going, and the n that we have on the top would be the sum of before. So if it got 68 from here, then this sum would also come here. So it's 6 plus 8. So I think that makes sense so far. And then we just want to return true if it's proper. Because we already said return false, so we just want to return true if it's true. Yeah, this should be the solution. Let's just comment. N is not already happy. That is valid. Taking the sum and then taking some squaring of getting curve does contain add if does not. So, yeah, that should be the solution. Yeah. Actually, like at first I was like, bro, what do I do? What do I do? But yeah, it's not difficult. Just make sure it contains um just make sure if it doesn't contain it, you have to actually add it to the hash set and then start all over again. And then if it doesn't, just return false. But yeah, thank you guys. This was not a hard problem. Damn.